In this video, we're going to look at using the TI-36x Pro to solve one equation with one unknown. We're going to look at two examples, but the advantage to using the TI-36x Pro and the button that we're going to investigate is this num solve button. So hit second and the sign button gets you to this num solve, and the calculator will actually solve an equation with one unknown. We're going to work through two examples just to show you how this works. In this problem right here, we have the two most abundant naturally occurring uranium isotopes are uranium-238 and uranium-235. And naturally occurring uranium is greater than 99% 238, but 235 is fissile with neutrons. For uranium to be useful for nuclear energy, it must be enriched to 3 to 5% uranium-235. What is the percent abundance of uranium-235 in a uranium sample with an average mass of 237.95? So we're not going to go through all the chemistry here, but essentially we apply chemistry knowledge to arrive at a mathematical equation, which is this. The average mass is equal to uh, 235 times x plus 1 minus x times 238.0508. So this mathematical equation, after you arrive at this, we're done applying the chemistry, and the rest of this is just algebra. This is where a calculator like this can really help us. So let's just solve this problem. I'm going to show you how to use this calculator to solve the problem. So first, you turn the calculator on, you hit second num solve. And this is going to pull up whatever we were working on last. And in this case, we just want to erase what we were working with last. So I'm going to clear this. And there's something on both sides of the equal sign. Let me clear both of those. And now I just want to type in the equation as written. So on the left side of the equation, I have 237.95, and toggle over. The right side of the equation has this, which is x times 235.0439 plus 1 minus x times 238.0508. Okay, so we've just entered that equation in. We can scroll back through and see that we entered this correctly. So we have 235.0439, our average mass 237.95. So on the calculator then, we've got the equation that we entered in, and we need to put at this point, we hit enter, we have to put in a guess for what we think x is. Now in this case, since we're looking for the percent abundance, and x in this case is the fractional abundance, that is a value from 0 to 1, I'm just going to guess something between 0 and 1. So let me just put in 0.5, and I'm going to hit enter. Solve for x, enter, and then it spits out the answer. So in this case, the answer is x equals 0.335. 0.0335. And this is equal to 3.35% because x is actually the fractional abundance. Okay, let's look at another example. And this is an example from second semester general chemistry. A 0.1 molar acetic acid solution is made. What is the final concentration of hydronium ions? Again, we apply our chemistry knowledge to arrive at an expression. And this expression is x squared over 0.1 minus x is equal to 1.8 times 10 to the minus 5, where x is the hydronium ion concentration. Okay, so again, we can, we need to quit. Then we need to go back to second num solve. Now I have the old equation that I was working with. I'm going to clear that out. And now I want to put in this new equation, which is x squared divided by, in the denominator we have 0.1 minus x, and then that equals 1.8 times 10 to the minus 5. Now, a couple of things about this. Notice that this is a quadratic equation. We have x squared. And as you might recall from algebra, quadratic equations have two roots. And while there are two mathematical solutions to this equation, there's only one solution that's chemically relevant. So in this case, I need, once I hit enter, I have to use my knowledge of the chemical situation in order to put in my initial guess. And in this case, I know that X, which is the concentration of the hydronium ion, is going to be something like a small number. And it's going to be positive. It's not going to be, there are no such things as negative concentrations. So I might guess something like 0.01. So let me just guess 0.01. Sorry, 0.1. And solve for x. And we get our answer, which is x, which is the concentration of the hydronium ion, is 0.0013 molar. And just to give you an example of, let's say we didn't know all of our chemistry. And we might guess something like, let's just guess negative 0.01. This gives me the other root, which is x is negative 0.00135. So as I mentioned, concentrations can't be negative, absolute concentrations can't be negative. So we do have to apply our chemistry knowledge in order to get the calculator to do what we want. Let me just illustrate this with one more example. Let's say that we just guessed something outrageous like 1 molar or 10, let's go 10 molar, right? So we just think that the hydronium ion concentration is 10 molar. Well, in this case, if we let the calculator try to solve this for x, we get an error because our initial guess was too far away from the correct answer for it to converge on the right answer. So that guess is important for quadratic and cubic equations and so on.